Hello dear students, let's start regarding Lacey's theory. It is one of the important topic of irrigation engineering. See, this theory it is basically for unlined canals. Okay, so remember it. It is for unlined canals. Okay, unlined, or we can say alluvial. So unlined means natural, or we can say natural. Okay, so here let me write the formulas which will be used for designing canal. So first formula is regarding velocity. V is equal to qf square upon 140 raised to 1 by 6. Let me write it more clearly. Just 1 second. V is equal to qf square upon 140 raised to 1 by 6. Okay, now here V is the velocity in meter per second. Q is the discharge or rate of flow in meter cube per second. Meter cube per second, you may call it as Q max. And F is the silt factor. Now to find the value of F, we are having another formula. F is equal to 1.76 under root d mm. Mm is diameter in mm. Okay, basically dmm is diameter in mm. Then next, R is equal to 5 by 2 V square by F. Okay, so what is R? R is your hydraulic mean depth. Okay, so to find hydraulic mean depth, we are using the formula R is equal to 5 by 2 V square by F, and perimeter P is equal to 4.75 under root Q. Okay, so this is perimeter. Now we know the formula for perimeter of trapezoidal channel also. Okay, so on next page I am writing the formula of trapezoidal. Suppose you are having a shape like this. Okay, so this is D, this is B. So we know both the formulas. One is for perimeter, P is equal to B plus 2D under root 1 plus n square. and we know the area also. Area is BD plus ND square. Okay, so what is N? Here N is the slope. This is 1 is to N. N horizontal, 1 vertical. Okay. Now we know discharge. Discharge is area into velocity. Okay. So basically, see, we are having two formulas for perimeter. Formula is P is equal to 4.75 under root Q. So this also we can use, and we can equate with this formula. Okay. So we can equate the perimeter. Same way area also we can equate. Area one is this formula, and another formula is area is equal to discharge upon velocity. Okay, so you can see we can equate these two also, this one and this one. Okay, so for perimeter also we are having two formulas, for areas also we are having two formulas, and ultimately, see, if we solve, so we will get the width. Basically we will get the width B I will get, and I will get the depth D. Okay, these two I can easily get. Now next is bed slope. Okay, so bed slope is F raised to 5 by 3 upon 3340 Q raised to 1 by 6. We know what is F. F is the silt factor, Q is the discharge. So bed slope we can get from this formula. Then one important formula, that is Lacey's regime scar depth. It is equal to 1.35 Q square by F. Now see, this is small q. Okay, Q square by F raised to 1 by 3. Okay, so what do you mean by small q? See, capital Q is the discharge, which is proper discharge. Okay, and small q is basically capital Q divided by length. Okay, here discharge per length, unit length, that it will give you small q. Okay, so don't make that mistake. This is small q, so 1.35 into Q square by F raised to 1 by 3. Now see, Lacey's normal scar depth R. Okay, this is also represented by R. So here also you should not get confused with hydraulic mean depth. Okay, so let me write on the fresh page. Okay, so R is equal to 1.35 Q square by F raised to 1 by 3, and I told you small q is equal to capital Q by L. Now where it is useful, this Lacey's scar depth, here this formula, once we find out the value of R, then we have to adopt downstream cutoff up to 1.5 times R. Remember this. Below the downstream water level. So it will be useful. Once you find out Lacey's core depth, you have to multiply it with 1.5 times the Lacey's core depth, and that too below downstream water level. Okay, thank you very much.